Hi, in this third video on the series on plane geometry, we will first focus on right triangles for some time and then go into congruence theorems. Now, before we mention anything, we need to talk about some terminology associated with right triangles. So, if you have a right triangle, then you have two sides which meet at 90 degrees angle. And the side opposite to this 90 degrees angle will be the longest side because this angle is the longest, is the greatest. And this has a label. It's called hypotenuse. So hypotenuse is the longest side. And then the other two sides which form the right angle, they are called legs. Now the legs could be equal, or you may have a short leg and a long leg. But hypotenuse will always be the longest side. It will be bigger than either of the legs. So that's some terminology. And one other thing we want to know about right triangles is that you have something known as Pythagorean theorem. So what is Pythagorean theorem? Let's look at this picture of a right triangle. I have labeled the angles with uppercase letters A, B, and C. The side opposite to uppercase is denoted by lowercase a, and similarly this leg will be lowercase b and the hypotenuse will be lowercase c. So whenever you have a right triangle where the legs are of sizes a and b and hypotenuse is c, then the Pythagorean theorem says a square plus b square equals c square. So this is the Pythagorean theorem. And this is applicable only for right triangles. We don't have any theorem that will connect the three sides of any triangle. But for a right triangle, we can always say that. So this could be used to check if a triangle is a right triangle or not. What you would do is you would square the smaller sides and then add them up and see if it is the largest side square or not. All right, let's actually look at an example of Pythagorean theorem. So let's say I have a right triangle where the legs are 3 and 4. So I'm going to draw a right triangle with legs 3 and 4. And say I don't know the side, the hypotenuse. So let's call it C. Then I can use the Pythagorean theorem, a square plus b square. I can either call this as a and this as b or vice versa. It really does not matter. What I want to do is I want to square each of the legs, 3 square, 4 square, and then add them. This is equal to c square. And 3 square means 3 times 3. So that's 9. 4 square is 4 times 4, 16 equals c square. We can simplify. 9 plus 16 is 25. So c square is 25, but I need c. So to get rid of the square, I take square root on both sides. Square root of 25 is 5 and square root of c square is c. So what I got is c is equal to 5. So notice, when we know two legs, we can find the hypotenuse. Now let's look at one other example where I may not know both the legs, but I may know the hypotenuse and a leg. So this time I know these two sides and I need to find the remaining leg. So let's use the letter A for this leg and apply Pythagorean theorem again. So I get a square plus 15 square equals 17 square. 15 square is 225. 17 square is 289. Subtract 225 from both sides. 289 minus 225 is 64. And if a square is 64, a will be square root of 64 or 8. So notice we could find the third side if we know two sides. So if you know any two sides, you can always find the third side. That's what Pythagorean theorem says. But it has one limitation. You can only use it for right triangles. Now we will focus on all the triangles in general, not just right triangles. Every triangle has three sides and three angles. We use uppercase letters for sides, for angles, A, B, C, and then the sides opposite to that, we use lowercase letters. So side opposite to angle A is lowercase a, and similarly I can label this side AC with B and this side with lowercase c. So every triangle has three angles and three sides. Now if you have two triangles that have the same angles and same sides, so let's say this is also A and this is B and this is C, and then this angle matches with this one matches with that, and this one matches with this. Then these two triangles are called congruent triangles. Congruent means if you were to cut this triangle and cut this triangle and put one triangle on top of the other, you cannot tell the difference. It looks like you only have one triangle because everything matches. So if the six characteristics, three angles and three sides match, we say the two triangles are congruent. Now it turns out that you really don't need all six characteristics. In some cases, you can just tell that they are congruent with only three characteristics. So here is an example. If I draw a triangle with side lengths 13, 14, and 15. So say I have drawn, and there's one other triangle with the same side lengths of 13, 14, 15. So say you have two triangles. Let's call one triangle as ABC, another as DEF. So if this is 13, AB is 13, and I'm saying DE is 13. AC, let's say this is 14, and DF is also 14, and BC is 15, and EF is 15. So in these two triangles, ABC and DEF, it's just the sides that match. These two sides, 13 and 13 match, 14 and 14, and 15 and 15. But we don't know anything about the angles. It turns out that these two triangles will still be congruent, which means even if you know just the sides matching, then you know that those two triangles are congruent. And this is called SSS congruence rule. SSS means side, side, side. So if three sides of one triangle match with three sides of the other, those two triangles are congruent. Now there is one other there are few other congruence rules. The next one we will talk about is, so let's go ahead and number these congruence rules. The first rule we mentioned is SSS. The second rule we will say is SAS rule. And SAS stands for side, angle, side. So now if you have two triangles where, and again, those two triangles don't have to be oriented the same way, but if you have side, angle, side, or you can see that angle is between the sides. So if two sides, so let's say this side matches with this side and this side matches with this side, and the angle between these two sides also match in both triangles. So like that. So if you have side, angle, side of one triangle match with side, angle, side of another triangle, then you say that these two triangles are congruent. So again, let me label these angles as ABC, and this angle is D, and this is E and F. We say that triangle ABC is congruent, and the symbol we use for congruence looks like this. There's a tilde and then there is equal sign. So triangle ABC is congruent to triangle DEF. Now I got to be careful. I cannot label whichever way I want, but I want to see that angle A matches with D, and A was the first letter here, so I'm going to use D for the first, and then I used B for the second letter. So notice AB is this side with a single tick mark, and then what is the side that starts at D, because A corresponds to D and includes this side with single tick mark, so that would be E. So I got to write D, E, F. I can't write D, F, E. So I have to be careful there. So SSS and SAS. Then there is a third congruence rule. This is ASA. And what does ASA stand for? Angle, side, angle. So this time I want to put side in between two angles. So let's go ahead and draw two triangles. So we have two triangles where two of the angles match. So let's say this angle matches with this angle, and this angle matches with this angle, and side is between these two angles. So this side matches with this side. Then these two triangles will be congruent. So only these three characteristics are needed, and then the other three characteristics will be forced to match, and those two triangles would then be congruent. Then a fourth rule is called AAS rule. So notice I have angle, angle, and side. So this time I'm going to draw two triangles. And again, they don't have to be oriented in the same way. They could be rotated. But here is the point. If you have this angle match with, say, this angle, and this, so two angles should match. And then the side is not the one between them. That would be ASA. So just take some other side. So angle, angle, side. So I'm going in this direction. Single arc, double arc, and then the side. So single arc, double arc, and then the side. After that, double arc angle. So these two triangles will also be congruent. So we have some rules of congruence. So let's write them all. Let's summarize. The first rule of congruence was SSS. The second rule we mentioned was SAS. And third rule is ASA. And the fourth rule is AAS. So these four rules of congruence applies to any pair of triangles. But in the special case of right triangles, we have one additional rule of congruence, and that is HL. H stands for hypotenuse, L for leg. So what this says is if you have two right triangles, so let's go ahead and label the right angle first. And H means the hypotenuse of one matches with the hypotenuse of the other. So this is the hypotenuse for this triangle, and the hypotenuse of this is here. And L stands for leg. If one of the legs matches, so it looks like both triangles have a short leg and a long leg. So let's say the short leg of the first matches with the short leg of the second. Then these two triangles will be congruent. So notice you can't have HL for any other triangle, only for right triangles. And you can see why. Because for a right triangle, you have Pythagorean theorem, which tells you that if you know two sides, the third side can be found. So you can find out this leg using these two sides, and similarly you can find this leg using these two sides. And since the two sides match, the third side will also match, and then you can say all three sides match and there is SSS. So that's an informal proof of HL congruence using SSS congruence.